Inferential statistics help us compare groups, test hypotheses, and uncover meaningful patterns in data. Whether you're determining the success of a marketing campaign, evaluating employee satisfaction, or forecasting trends, these techniques are critical for making informed decisions. Let's explore some of the most widely used inferential methods and how to apply them effectively today in Art+Science. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the Art+Science Analytics Institute, where our mission is to make you a better data analyst. Over the last few videos, we've laid the foundation for understanding inferential statistics, from its core principles to real-world applications and limitations. Now, it is time to build out the toolbox and explore the key techniques that make inferential statistics a practical part of your analytical approach. Using inferential statistics provides a valuable set of tools for examining data and making inferences about larger groups or populations. 4 fundamental techniques, chi-squared tests, t-tests, ANOVA, and Tukey Tests, are commonly used to uncover trends, compare groups, and verify findings. Now let's dive into the unique contributions of each method. The chi-squared test is a statistical method that examines the connection between categorical variables and determines if their distributions are independent or linked. It can be applied to determine if there is a relationship between 2 categorical variables, such as product preferences and age group. For instance, imagine we are researching the potential link between a store's location and the satisfaction levels of its customers. To do this, we have divided our customers into 2 categories, 2 groups, satisfied and dissatisfied. By performing a chi-squared analysis, we could assess whether there are any statistical differences between these 2 categorical variables that could be considered statistically noteworthy. T-tests are statistical methods used to compare the means of 2 groups and determine if the differences are significant or not. This helps determine whether there is a meaningful distinction between 2 sets of numerical data. For example, say a business is looking to see if changing their pricing strategy leads to increased sales compared to their old strategy. By performing a t-test, they could find the answer to this question. ANOVA stands for Analysis of Variance, and it is a statistical test that allows for the comparison of means between 3 or more groups, helping to determine if there are statistical differences between them. As the definition might imply, it is used when analyzing multiple groups in order to identify if at least one group stands out as statistically different from the others. Imagine you are analyzing customer satisfaction ratings from 4 different regions. ANOVA would be the test you could use to assist in determining if the variations between regions are statistically noteworthy or not. If ANOVA shows significant differences between the groups, Tukey's test is a useful tool to identify which specific groups differ. This extra step allows for a more comprehensive and detailed examination of the data. For instance, if you conduct an analysis of variance test to compare customer satisfaction ratings in those 4 different regions and discover a significant variation, it's the Tukey test you would use to determine if those satisfaction levels are markedly higher in region A compared to B, or region C compared to D, and so on. These techniques can work together to provide a more comprehensive analysis. For example, when dealing with categorical data, the chi-squared test is a recommended tool. In cases of simple numerical data comparisons between 2 groups, a t-test is suitable. When there are more than 2 groups involved, ANOVA can be the test that determines the overall differences. And if the ANOVA test shows significant difference, it's the Tukey test that you can use to identify specific group differences and variations. These methods do rely often on pretty heavy statistical techniques and tools. But if coding is not in your skill set, then you can still conduct inferential statistics using the Data Analysis Toolpack in Excel or the Excel Minor Analysis Toolpack in Google Sheets. We have demonstrated these in several videos in the past. To input data into the chi-squared test feature, use a pivot table first to summarize your data, and then simply select the chi-squared test from the toolpack. For t-tests and ANOVA, simply choose your data and select the appropriate test from the toolpack. These tools are built in and really easy to access. Tukey tests, however, are not directly supported by Excel or Google Sheets. To perform this type of analysis, consider using some statistical software such as R, Python, or SPSS that have built-in functions for Tukey tests. Alternatively, there are lots of online calculators that specialize in what we call post hoc Tukey analysis, which allow you to enter your ANOVA results into that online test and see the Tukey results. Each of these methods has its own advantages, providing analysis and flexible options for analyzing data correlations, conducting tests, and making well-informed choices. With a clear understanding of when and how to use each one, you can confidently uncover valuable insights and add clarity to your data analysis. Thanks so much for watching. If you haven't already, take a moment and subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Every single week, we are bringing new, exciting, and important videos on data analytics to this channel, and we would love to have you there for the journey. Be sure to check out the links in the description for this video below for additional art science resources, and sign up for our newsletter to get exclusive tips, course updates, and more directly in your inbox. Thanks again for watching, and we'll see you in the next video.